Hello. Do you remember in economic dispatch we talked about equal incremental cost criteria? We didn't consider network constraints at that time. In the last video we talked about security constraint optimal power flow, which includes power flow limits. Now what will happen to the price when line flow limits are bounded? Let me tell you the results first and then explain why. If line flow limits are active, or say we have congestion, then there's no longer one equal incremental cost. The network is separated and costs may be different at different locations. Why would this happen? When there's congestion, we cannot increase line flows as we want, so sometimes even remote generators can still produce at a low price. We have to use more expensive local generators, or other remote generators which are also expensive. Anyway, our local marginal prices are higher than somewhere else. Let's see an example here. There's congestion in line 3, and choices are using G1, which is impossible because of line 3 power flow limits, or using G2, which is expensive, or use G1 plus G3, which generates counterflows so that power flow increase in line 3 can be cancelled, and the cost may be lower than using G2. To check the price in this situation, we can list power balance and line flow limits. If you're not familiar with generation shift factors, you can watch my optimum power flow videos. There are 3 definitions here. We call generating units setting local marginal costs as marginal units. As you can imagine, when there's congestion, marginal costs can be different for different locations, as if they are separated. For example, this is a calculation for generation revenue and demand payments, and you can see there's a mismatch between their values. Why is that? Think about generator 1, which generates 220 megawatts, but it's not supplied to node 1, but rather node 2 and node 3. This is reasonable because everyone likes the lowest generation cost. But what makes this different from situations without congestion is that, due to congestion, prices at node 2 and 3 are no longer $20 per megawatts. That is to say, for the same portion of electricity, generator 1 generated and get paid at a lower price, but loads in 2 and 3 bought at a higher price. This difference value is called marginal surplus. If the transmission operator can have that money, they will want to deliberately produce congestion for profit. This is bad and can be solved with financial transmission rights, which I'll talk about later. Before talking about FTR, let's see what is contract for differences. It's very simple. For example, generation and demand side agreed yesterday on $10 per megawatts, and today the market price is $15 per megawatts. So the generation side refunds the demand side at $5 per megawatts, and vice versa if the market price is lower than the agreed $10 per megawatts. And this trade is done as if there's no such a market. But this doesn't work if there's congestion. Let's say they agreed on 10, but the next day generators get paid at 5 and the demand paid at 20. No one is compensating and no one is compensated. Everyone is unhappy. Where does this gap go? It goes to the operator. Now here comes the idea of financial transmission rights. If the traders buy the right from the operator ahead of time that they can get a surplus between the generation and demand nodes at a certain amount, then this situation is transformed as the first one. The problem is solved. The operator just needs to avoid selling more FTRs than it could. So the operator should make predictions ahead of time. Thank you for watching and see you in the next video.